is where we do all of our R&D. So you can see all of these fridges. These fridges are required to remove all of the environmental noise that corrupt the way that quantum computers work.
Yet another major player has emerged in the quantum race, Amazon. It is the latest tech giant to make waves with the announcement of its own quantum chip in February, the company's answer to growing competition in the space from familiar rivals in the cloud computing business. Google, Microsoft, and others are now competing in a new tech arena and sprinting after what they say could be the next frontier. CNBC got an exclusive look inside Amazon's AWS Center for Quantum Computing, located at the California Institute of Technology in Pasadena, California.
All of this is electronics that's used to send specialized control signals down into the fridge. If you look here, you can see this cabling. This comes down into the fridge, and then your processor sits at the bottom here.
Amazon is widely known as an e-commerce giant, but the business took a pivotal and profitable turn in 2006 with the launch of Amazon Web Services. AWS is now a $100 billion business, and it is a key part of why the company is now worth over $2 trillion. And Amazon sees quantum as the next major growth area for its cloud services.
One of the primary advantages that a company like AWS has is that they know how to put these sort of classical control systems together. They know how to build data centers. And then the piece we need to solve is, how does that quantum processor fit together?
Compared to other big players, Amazon is late to the game. Microsoft has been working in quantum for nearly 2 decades, while Google has been in the space since 2012.
If we look at kind of the quantum race over the past several years, as Amazon has been surprisingly missing in that conversation around quantum. And over the past couple years, they've increased their investment.
Amazon had been looking at this for a while and then finally decided to get involved. There's a strong business case for AWS or Amazon to get involved with quantum computing. Quantum computing is very much in line with that sort of business model where you would have off-premise quantum computing resources that can be made accessible through the cloud.
Not only will it be initially start out as a standalone, more high-performance part of their cloud services, but eventually all of the cloud will be run on some form of quantum.
Quantum computing holds a lot of promise. It has already been shown to solve calculations within seconds that would take millions of years on even the most cutting-edge current machines.
While classical computers operate serially, in the sense that they do one thing at a time, these quantum properties allow quantum computers to operate effectively simultaneously, so to explore many possibilities at once.
The quantum space has seen a flurry of excitement recently, with investor interest soaring and pouring into publicly traded stocks. Those names have added billions in value in the past year.
Over the past 6 months, this theory is starting to get into actual tests that are showing that we can shift from a science project into the beginnings of an engineering phase. And that's really exciting.
Part of the hype is the perceived payoff down the line. McKinsey projects quantum could be a $173 billion market by 2040.
Today, there is about a $500 million market. We think that that's a number that could increase by a factor of 5 or even 10, depending on how companies are able to develop error correction at scale. So that would get you to about $2.5 to $5 billion in market size by the end of the decade.
Quantum computer can solve really hard math problems. Materials design, chemistry is another area which is naturally maps onto a quantum computer and what it does well. There's optimization, logistics, things that Amazon would really care about.
What it means for Amazon specifically is that the opportunity to build just a supercharged part of AWS that can crack incredibly difficult problems, whether it's related to drug discovery or on cybersecurity, these incredible difficult problems, that is an opportunity for them to charge a lot more for.
But we are still years away from a functioning quantum computer, with estimates varying wildly. NVIDIA CEO Jensen Huang has said useful quantum computers could still be 15 to 30 years away, while Google says commercial quantum applications are only 5 years away. IBM thinks by 2033.
I would imagine that over the next 5 years, we might start to see demonstrations using this for materials design or for chemistry problems. And then I think within, let's say, a decade, that would be the most aggressive timeline. I think we might have really fault-tolerant quantum computers that can do many of the problems we're hoping to do.
A challenge in quantum is that these are hard to scale. These computers are incredibly sensitive to interference in their environments. This can be anything from vibrations, heat, radiation, or even the Earth's magnetic field.
This big shield here is made of a special metal that the magnetic field gets attracted into and isolates the quantum processor at the bottom of this fridge.
But the main limitation to quantum computers is errors. Researchers' primary focus has been on detecting and then trying to correct for those.
These computers are too error prone. If you can solve the errors within these quantum computers, then you really can make it a practical technology. And we're entering that era now. That's why you're hearing a lot about all of these breakthroughs across the industry. And so that's super exciting. It's a major paradigm shift, but now you've got to make that error correction work even more efficiently.
You have to encode the information that it processes in a highly redundant way so that when the errors occur, they don't damage the information that you're trying to protect and process.
The error rates are still at a point where they're not commercially viable, but we will see this leapfrogging, and I expect that of those 4 companies that are working towards this, probably 2 or 3 of the 4 will ultimately have an error rate within the next, call it 5 years, that is more palatable for commercial applications.
Amazon's first foray into quantum was through the Amazon Bracket service, which gave developers access to quantum computers from other companies such as IonQ and Rigetti Computing. But after mostly watching from the sidelines, Amazon decided to start investing in its own technology. In 2019, Amazon officially got into the race and partnered with Caltech to create the AWS Center for Quantum Computing.
They decided to locate their Center for Quantum Computing here on the Caltech campus, where we have a thriving community of people who are working on quantum science, and they knew their people would benefit from being part of that culture.
6 years later, that effort is now starting to yield results. The first major advancement, the Ocelot quantum processor. Like competitors Google and Microsoft, the chip is designed and fabricated in-house. Amazon says the chip's scalable architecture reduces error correction by up to 90%. Google's Willow chip, which was unveiled in December, also demonstrated improvements in this area. Ocelot uses cat qubits, named after a theory called Schrödinger's cat thought experiment. This design intrinsically suppresses certain forms of errors, reducing the resources required for quantum error correction.
Cat qubits are a novel form of quantum bit or qubit. And in our implementation, the way that they're macroscopic is that the electrical voltages and currents involved are larger than at their fundamental quantum level. And that macroscopic nature, if you do it right, actually enables you to protect the information from errors in ways that you can't otherwise.
So this is our largest chip format, the 176p variant. This has been our workhorse here for the last few years, and we're still utilizing the 76p format, but as we increase density, we'll be going to a larger chip format.
Behind all of these other electronics is where your quantum processor will sit right down here. And that's the lowest temperature stage, 10 milledegrees above absolute zero. So that's something like, the deepest part of space. Make that colder by another factor of 100, and then you've got the temperature of the quantum processor itself. The heart of these quantum computing systems, it's really this quantum processor, which is, think of it just as an array of physical qubits that you can control and manipulate and get to interact. But the details of how that happens is really what differentiates one hardware platform from another, and really, is where the secret sauce is and where all the intellectual property is.
That's the level where the tech companies are competing.
That's right. There's many hardware platforms people are developing, but the main competition is around how that processor is designed and architected and implemented.
Painter says having the backing of AWS has been a major advantage for its quantum efforts.
One of the big advantages we have at AWS is the fact that we do design our own chips for our data centers. And so those very same chips and those very same design techniques can be used for actually implementing the control and the chips that are needed to control the quantum processor.
The three ones that really matter in this conversation are Microsoft, Google, and Amazon. And of course, those are the three that all have the cloud services. Amazon, I think that there's probably a little bit at a disadvantage relative to some of the other ones, in part because the company's DNA has not been around these really technically hard problems. The AWS has technical problems, but as a company, the DNA has not been around really cracking very difficult problems. And I think that probably Microsoft might be in line or a little bit better, but Google has a history of really trying to solve, I think, more difficult problems.
Amazon eventually envisions quantum resources being available as a cloud service.
A company like AWS, which is its business is delivering compute power to customers at scale and taking that burden off of the customer in terms of the hardware. This is a great example why this fits with AWS model, because the quantum computer itself would be put inside of a data center, and then we would use similar elastic computing resources to provide that access to customers.
Think of this as a more kind of a new vertical within their cloud business. In the end, it will probably be solved and monetized through one of these big cloud platforms, and AWS has a great shot at being successful there.
There's also potential for quantum to contribute to the development of AI and vice versa.
As quantum computers become more capable, they'll generate data sets that we can use to train AI. But then if you could start to feed it data, I think in terms of development of quantum computers, I suspect that AI and machine learning will play an important role going forward.
Despite all of the progress, there is a lot of work to be done.
These are small scale systems that involve, maybe 10 to 100 physical quantum bits. Ultimately, we need to be able to control things at like 100,000 or maybe 1 million quantum bits. So imagine this thing scaled out by a factor of 10,000. In the future, the cost and the size is not really scalable the way it is right now. So we have to innovate on this size and the cost at the same time as we're improving the performance.
But quantum is a long-term bet, and it is unclear when the billions in R&D could eventually pay off.
There really have been very important milestones reached in the last little while, but we should also mention the challenges we face too. We're still pretty early on, and there's large error bars in where we'll end up in time and when we'll have a viable quantum computer.
This is just going to be some good optionality for investors who are excited about AWS and the opportunity they can bolt on a new business. But that business probably isn't going to yield anything for at the earliest 5 years and more likely 10 years out.
The approach that Amazon is taking now here at the Center for Quantum Computing is a bit different than what other companies are pursuing. It's promising, but whether it'll really pan out, we're not sure. A company like Amazon can afford to take that type of risk. I'm impressed by the extent to which the Amazon leadership appreciates that this is a long-term enterprise.
What has been the message from CEO Andy Jassy? How involved is he at the quantum project?
So Andy's, very aware of our quantum program and was here at the beginning, its initiation. And so he's involved, and we do meet with Andy to talk about our quantum program. They don't understand the technical parts, but they're well aware of how hard the challenge is. They understand that this is going to take some time and it will take quite a bit of resources.
I applaud Amazon. This is the first time I can think of that the company has really embraced some cutting edge hardware tech. They're late to the game, but again, we're still so early in this that the fact that they're late really doesn't change their likelihood of success here. This is still, by any measure, extremely early in the quantum phase.